Hi children, we continue with our fourth chapter, carbon and its compounds. In the last class, we discussed about the different types of covalent bonding, single bond, double bond and triple bond. And we saw certain molecules of elements and molecules of compounds in which the combining atoms are joined together by covalent bonds. By sharing of electrons, bond is formed between the combining atoms. Now in this today's class, we will learn about properties of covalent compounds. Properties of covalent compounds. What are covalent compounds? The compounds in which the combining atoms are joined together by means of covalent bonds. What are covalent bonds? The bonds which are formed by mutual sharing of electron pairs between the combining atoms. So, the compounds which are formed by sharing of electrons, mutual sharing of electron pairs between the combining atoms are known as covalent compounds. Examples of covalent compounds are methane, CH4 methane, then ammonia. All these examples we discussed in the last class: methane, ammonia, water and carbon dioxide were the examples given for covalent compounds. There are more examples of covalent compounds, but these are the compounds that we have discussed in the previous class: methane, ammonia, water and carbon dioxide. Now let us see the properties of covalent compounds. So covalent compounds exist in liquid or gaseous state. So in the last chapter we learned the properties of ionic compounds, and when we discuss the properties of covalent compounds, you will see that properties are entirely different, just the opposite of ionic compounds. So ionic compounds exist in solid state, covalent compounds exist mostly in liquid or gaseous state, and if solids, rarely a few substances exist in solid state, they are amorphous. Amorphous means non-crystalline. They will not have a shiny appearance. They will be non-crystalline. The term used for non-crystalline substances is amorphous. So this is the first property of covalent compounds. Mostly they exist in liquid or gaseous state, and if solids, they are amorphous or non-crystalline. Second one is covalent compounds have low melting point, low melting and boiling points. Covalent compounds have low melting and boiling points. The reason is that the force of attraction between the combining atoms is weak. This is last year's board question. Covalent compounds have low melting and boiling points. Give reason. Reason is that the force of attraction between the combining atoms is weak. That's why lesser amount of energy is required to break the bond of attraction between these atoms. So they have low melting and boiling points. In the case of ionic compounds, you learned it as ionic compounds have high melting and boiling points. There the force of attraction is between oppositely charged ions. So it is a very strong force of attraction, and to break that force of attraction, huge amount of energy is required. Here the force of attraction is weak, and to break that, only lesser amount of energy is required. Only by heating them to a very low temperature, that will break, and melting point or boiling point is attained. So mark it as important. Because of the weaker force of attraction between the combining atoms, covalent compounds have low melting and boiling points. Next one is they do not produce ions in solution. They do not produce ions in solution. So their solutions do not conduct. So their solutions do not conduct electricity. So, ionic compounds, in the case of ionic compounds, you learned it as they conduct electric current due to the presence of oppositely charged ions. Here, when they are dissolved in water, no ions are produced, so their solutions do not conduct electricity. Last one, they are insoluble in water and are soluble in organic solvents like benzene, carbon tetrachloride, etc. Carbon tetrachloride, etc. Okay, so this is the last property. They are insoluble in water and they are soluble in organic solvents like benzene and carbon tetrachloride. So, all the properties are just the opposite of that of ionic compounds. First one is they generally exist mostly in liquid state or gaseous state, and if solids, rarely a few solids are there, their state is amorphous. They exist in amorphous state, that is non-crystalline state. Second one is they have low melting and boiling points due to the weak force of attraction between the combining atoms. They do not produce ions in solution, so their solutions do not conduct electricity. They are insoluble in water. Last one is they are insoluble in water, but they are soluble in organic solvents like benzene and carbon tetrachloride. Now the next topic is allotropes of carbon. There is a phenomenon known as allotropy. This also you have seen in the previous chapter. What is allotropy? The existence of an element in different forms. The existence of an element in different forms with different physical properties but same chemical properties. This is known as allotropy. Existence in different forms, same element existing in different forms with different physical properties, changes only in the physical properties with different physical properties but same chemical properties. Allotropy is nothing but the phenomenon by which same element exists in different forms with same chemical properties, same physical properties but different physical properties. So, carbon is an element which exhibits allotropy, and the different allotropes of carbon are crystalline forms. First allotrope of carbon are its crystalline forms like diamond and graphite. Second form is non-crystalline forms coal, charcoal. Then the third type is known as fullerenes. Fullerenes are another type of allotropes of carbon. The first identified fullerene is C60, which resemble the geodesic dome designed by the US architect Buckminster Fuller. In the honor of that architect, this fullerene is given the name Buckminster fullerene. So, fullerenes are the third type of allotropes of carbon, where carbon atoms are arranged in the shape of the first identified fullerene is C60, where 60 carbon atoms are arranged in the shape of a football. It resembled the geodesic dome designed by the US architect Buckminster Fuller. So, in honor of this architect, this compound C60, the fullerene, was named as Buckminster Fullerene. Okay. So, what is allotropy? The existence of an element in different forms with different physical properties but same chemical properties is known as allotropy. Carbon is an element which exhibit allotropy. The three different allotropes of carbon are crystalline forms. Examples for the crystalline forms of carbon are diamond and graphite. Non-crystalline forms, coal and charcoal, and the third type is the new term for you, fullerene. Only one example you have to learn. The first identified fullerene was C60, where 60 carbon atoms were arranged in the shape of a football, and it resembled a geodesic dome designed by the US architect Buckminster Fuller, and in the honor of this person, this compound C60 fullerene, the C60 was named as Buckminster Fullerene. Okay. Now the next is, we have to see the difference between graphite and diamond. So, what are graphite and diamond? These are the two crystalline forms of crystalline allotropes of carbon, and the difference in the physical properties, they differ only in their physical properties. Chemical properties are same. Allotropes have same chemical properties but different physical properties. So, we have to see the difference in the physical properties of graphite and diamond. Why they have different physical properties? They have different physical properties because they have different structures. The difference in the manner in which carbon atoms are arranged in them. All these compounds, all these substances, allotropes, are made up of the same element, carbon. They are made up of the same element, carbon. So, their chemical properties are same. All of them will show the properties of carbon. Chemical properties will be same because all of them are made up of the same substance, carbon. But they differ in the manner in which carbon atoms are arranged in them. The allotropes differ in the manner in which carbon atoms are arranged in them. That is the reason for the difference in the physical properties of graphite and diamond. You can see in your textbook, page number 61, you can see the structures, difference in the manner in which carbon atoms are arranged in graphite and diamond. In graphite, carbon atoms are arranged in a layer-like structure. That structure is known as layer structure. In between there is gap. In layers, carbon atoms are arranged. Graphite has a three-dimensional, very strong three-dimensional ring structure. Okay, so the manner in which carbon atoms are in fullerene structure of fullerene is also given there. All the carbon atoms are in the shape of a football. So, the difference in the manner in which carbon atoms are arranged in them leads to the difference in the physical properties of graphite and diamond. So, let us see the difference. Diamond, then graphite. Actually, this topic is given in a box under the heading more to know. So, you have to read it thoroughly. So, we are not sure whether questions will come from this more to know paragraph or not, but you have to read it. So, graphite and diamond, the differences in the, we have to learn the difference in the physical properties of graphite and diamond. Chemical properties, they are similar. So, the first one is diamond is extremely hard. As you all know, diamond is the hardest substance known. This one is soft with a slippery touch. All these differences are due to the difference in the manner in which carbon atoms are arranged in them. Extremely hard, soft with a slippery touch. Second one is transparent. Diamond is transparent with an extraordinary luster. You all know that diamond has a bright luster. This one is opaque, black in color. What is the difference between transparent and opaque substances? Through transparent substances we can see things clearly. Light completely passes through transparent materials, and opaque materials we cannot see through opaque materials clearly. Light do not pass through opaque materials. Third one is poor conductor of heat. This is graphite is a moderate conductor of heat. Then next one is diamond is a poor conductor of electricity. But graphite is a very good conductor of electricity. This you have learned in 8th standard. Usually non-metals are poor conductors of electricity, but graphite is a very good conductor of electricity. Next one, heavy substance. Diamond is a heavy substance with high density. This is lighter object with low density. So these are the differences between graphite and diamond. Diamond is a extremely hard substance. Graphite is soft with a slippery touch. Diamond is transparent with an extraordinary luster, whereas graphite is opaque with a black color. Diamond is a poor conductor of heat. Graphite is a moderate conductor of heat. Diamond is a poor conductor of electricity. Graphite is a very good conductor of electricity. Then the last point is diamond is a heavy substance with high density, and graphite is a lighter substance with low density. Now what are the uses of diamond? Diamond, as you know, has a bright luster, so it is mainly used for making jewellery. The second use is it has a very sharp edge, so it is used for making cutting, grilling and grinding equipments. Okay, so these are the two uses of diamond. Diamond has a bright luster, extraordinary luster. Because of that it is used for making jewellery, and because of its sharp edge it is used for making cutting, drilling and grinding equipments. Then what are the uses of graphite? Graphite is a very good conductor of electricity, so it is used for making electrodes. It is used for making electrode. It is used for making electrodes. Then it is used for making pencil lead. In the middle of the pencil, inside the wooden part, you might have seen a lead. Pencil lead is made up of graphite, and it is used as a lubricant in machinery. So these are the three uses of graphite. It is used as since it is a very good conductor of electricity, it is used for making electrodes. Second one, it is used for making pencil lead, and the third one is it is used as a lubricant in machinery. Okay, so that's all. Thank you, children.